Good evening, sir.
Yeah, ma'am. Good evening. Let's start, ma'am.
Good evening, sir.
Yeah.
Yes.
Yesterday, did you work out the IUPAC names for those molecules? Huh?
No, sir.
Oh, then how will you, man? You should put some effort, no? All right, you do it, all right? That's simple, actually. I just want you to know. I want you to try, that's all. Now, anyways, we were learning with the chemical properties of the primary amines, aromatic as well as the aliphatic primary amines. We learned many reactions, carbylamine reactions, reaction, Hoffman-bromide reaction, all that. Now, the next one is reaction with, what happened? Reaction with benzene sulfonyl chloride. Benzene sulfonyl chloride. This benzene sulfonyl chloride is called as Hinsberg's reagent. They can ask you, what is Hinsberg's reagent? So Hinsberg's reagent is benzene sulfonyl chloride. So primary amines react with benzene sulfonyl chloride to form a white solid. Reactions are complex. They will not ask you. Remember, primary amine with Hinsberg reagent gives you a white solid. The complex reaction. So secondary amine with Hinsberg's reagent gives N, N dialkyl benzene. And this is insoluble in excess of NaOH. This is insoluble in excess of NaOH. Now, likewise, the tertiary amines will not react with benzene sulfonyl chloride. So tertiary amine with Hinsberg reagent or benzene sulfonyl chloride, no reaction. So here it's N, N dialkyl benzene. Here it will be what? N alkyl benzene. So this is the difference. This is also one of the method of differentiating primary, secondary, and tertiary amines. So primary amines with Hinsberg reagent gives a white solid of N-alkyl benzene, and it is soluble in excess of NaOH. Secondary amine with Hinsberg reagent gives N, N dialkyl benzene, which is insoluble in excess of NaOH, and tertiary amine does not react with Hinsberg reagent. So what is Hinsberg reagent? Benzene sulfonyl chloride. Benzene sulfonyl chloride is called as Hinsberg reagent. If at all they ask you for the molecular formula or the structural formula of Hinsberg's reagent, the structural formula of Hinsberg reagent is a benzene ring, S, double bond O, and Cl. This is called as benzene sulfonyl chloride. This is the structure of benzene sulfonyl chloride. You can remember because in the 1 marker, they can ask any of these questions. Now, coming to the chemical properties, electrophilic substitution reactions. These electrophilic substitution reactions are complex. You need to understand this. Under that, the first reaction is nitration or bromination. We will learn bromination first. So first one is bromination. Now, aniline reacts with bromine water. Orange-red color of bromine water disappears, forming a white solid. So aniline, this is aniline. It's an aromatic amine. Electrophilic substitution reaction will happen only with aromatic amines. So this aniline, when it's treated with bromine, so bromine is a reddish color, orange-red colored solution. This aqueous bromine, when you treat it with aniline, so Aniline, NH2 is an electron donating group. Therefore, it is ortho-para directing group. When we say ortho-para directing group, we can write 3 moles of benzene like this for our understanding. For our understanding, you can write here. Here also, you can write the third bromine molecule like this. Now, what happens is, this H and Br gets eliminated as HBr. This H and Br gets eliminated as HBr. And here H and Br gets eliminated as HBr. So you get 3 moles of HBr. In place of this hydrogen, bromine goes. In place of this hydrogen, this bromine goes. In place of this hydrogen, this bromine goes. So we get a molecule like this, a benzene ring. You get NH2. You get a bromine here. You get bromine here. And you get bromine here. This is 2, 4, 6 tribromo aniline. This is bromination. So when aniline is brominated, aqueous, treated with aqueous bromine, the orange-red color of bromine gets decolorized. This is a white-colored solid. It's a white-colored solid. This reaction is used for qualitative test for aromatic amines. Now, monohalogenated derivatives of aniline or aromatic amines are prepared using the following sequence. See, this is a trihalogenated aromatic amine. Now, monohalogenated aromatic amine, if you're talking about monohalogenated aromatic amine, there is a sequence of reaction which has to be followed. It is not a one-step reaction. It is a sequence. Now, what is that sequence of reaction? The sequence of reaction is, this is also called as bromination, but we're talking about monohalogenated derivative. So aniline has to be protected now. NH2 group has to be protected of aniline. Now, this is aniline. NH2, this is aniline. It's an aromatic amine. This is allowed to react with acetic anhydride. CH3, CO, CH3, CO, and O. Acetic anhydride. So what happens is, this hydrogen reacts with this oxygen. The bond between carbon and oxygen breaks. So the byproduct what we get is acetic acid. In place of this hydrogen, this carbon goes. So we get a benzene ring. You have NH, you have CO, and CH3. This is the first, this is called as acetanilide. So directly bromination of aniline is not possible. So now what happens? Now when this acetanilide is treated with bromine in acetic acid, in earlier case the solvent was water, aqueous. Now here the solvent is acetic acid. So what happens is, now you get, see, this is also an electron donating group. So it will direct the reaction to take place at ortho and para. So you get a mixture of ortho bromoacetanilide, and also you get a mixture of para bromoacetanilide. You get para bromoacetanilide. This is important reaction for competitive exam. They may not ask you for your POC because this is a lengthier one. Now what happens? This when you acidify, this when you treat it with an acid, what happens is, now this acid, it's H3O plus. So what happens? CH3COOH. Acetic acid gets water. I can write it as OH and H. So what's that you get? CH3COOH. Acetic acid gets eliminated as a byproduct. CH3COH gets eliminated. In place of this carbon, this H goes. So the product what we get is, you get a benzene ring, you get NH2, and you get bromine, para-bromoaniline. Here also same thing when you hydrolyze or acidify it. So here are the bond breaks here, H and OH and H, sorry, OH and H. So here you get a mixture of para-bromoaniline. This is orthobromoaniline, this is para-bromoaniline. So this reaction is important because sulfonation, nitration, all follows this sequence. When we say all follows this sequence, The first step of the reaction remains same for nitration also, sulfonation also. What is the first step? Aniline is treated with acetic anhydride. You get acetanilide. This acetanilide, when you for nitration, you have to treat it with nitrating mixture. What is nitrating mixture? What is nitrating mixture?
HNO3.
HNO3 and sulfuric acid. Concentrated nitric acid and concentrated sulfuric acid mixture is called as nitrating mixture. Concentrated nitric acid and concentrated sulfuric acid equal volumes is called as nitrating mixture. Equal volumes of nitric acid and sulfuric acid is called as nitrating mixture. So the first step remains same. Now the second step is when this is treated with nitrating mixture. Nitrating mixture, HNO3 and sulfuric acid. What happens? At ortho position, you will have a nitro group, and also you will have at para position a nitro group. So you will have NO2 here, and also you have NO2 here. Now when you acidify it, you get orthonitroaniline. You will get orthonitroaniline and you will get paranitroaniline. Are you following the sequence of this reaction? They can ask you a question, why aniline cannot be directly nitrated? Aniline cannot be directly nitrated because nitric acid is nitric acid. It's an acid. Aniline is the base. A salt will be formed. So to prevent that, this NH2 group is prevented by reacting it with acetic anhydride. So when it's reacted with acetic anhydride, you get acetanilide, then you can perform nitration. You get a product, orthonitro and acetanilide, paranitro-acetanilide. That when you acidify, you get orthonitroaniline and paranitroaniline. Did you follow this reaction?
Yes, sir.
Yeah. The next set of reaction we'll have to learn. We will learn the next set of reaction. Give me some time. There's too much. The type notes is too much. The printed material. So I'm not getting space also. So I'm writing it. The next set of reactions or the next topic what we'll be learning is the diazonium salts. Diazonium salts. Now, what is this diazonium salts? Di stands for two, azo stands for nitrogen. Salts containing two nitrogen will be called as diazonium salts. Now, the preparation of diazonium salts, this we learned yesterday, and that reaction is called as diazotization reaction. Diazotization reaction. So what is this diazotization reaction? Now, I told you yesterday, nitrous acid cannot be prepared and stored because it will oxidize to nitric acid. So whenever is required, we prepare nitrous acid by the reaction of sodium nitrite with concentrated HCl. The sodium nitrite with concentrated HCl will give you HNO2 nitrous acid and you get NaCl, sodium chloride. Now this nitrous acid is when it's treated with aniline. Aniline is C6H5NH2. Nitrous acid, we can write it as O double bond NOH. HNO2. This is nitrous acid. We have written in the form of a structure. And this in the presence of HCl at 0 to 5 degrees Celsius. 0 to 5 degrees Celsius. What happens? This H2 and O gets eliminated as water. This OH and this H also gets eliminated as water. 2 moles of water gets eliminated. When 2 moles of water gets eliminated, what is formed? What is left out? You have a benzene ring. You have nitrogen here. And you have a double bond here. Nitrogen and you have the Cl. This is a red colored dye, and it's called as benzene diazonium chloride. This is called as benzene diazonium chloride. It's abbreviated as BDC. So benzene diazonium chloride is prepared by the reaction of aniline with nitrous acid at in the presence of HCl at 0 to 5 degrees Celsius. Can you remember this reaction? Benzene diazonium chloride.
Yes, sir.
Based on this, we are going to learn some of the chemical properties. So only one method required for the preparation of benzene diazonium salts, that is diazotization reaction. So based on this, we have to learn more number of chemical properties. The first chemical property what we will be learning is called as Sand-Meyer's reaction. We will learn the Sand-Meyer's reaction. Important. This is actually an easy chapter compared to all other organic chemistry. So chemical properties. Under the chemical properties, we are going to learn the first chemical property is called as Sand-Meyer's reaction. It's a named reaction. Sand-Meyer reaction. Or it's also called as replacement of halide or cyanide reaction. Replacement of halide or cyanide. Replacement of halide or cyanide. See, benzene diazonium chloride, we can write like this. A benzene ring, we can write nitrogen, double bond, N and Cl. Double bond, sorry, I've written triple bond here. It's a double bond, benzene diazonium chloride. This benzene diazonium chloride, when you heat it with cuprous chloride in HCl, Cu2, Cl2 in HCl. So what happens is these two nitrogen gets eliminated as nitrogen gas, and this chlorine gets bonded to this carbon. So we get chlorobenzene. We get chlorobenzene. This is a first Sand-Meyer reaction. The second Sand-Meyer reaction, when benzene diazonium chloride is treated with cuprous chloride in the presence of hydrogen bromide or hydrobromic acid. So what happens is nitrogen gas gets eliminated, no doubt about it. The Cl also gets eliminated as Cl minus. So what else is left out? You have a benzene ring and this bromine. In place of that, this group, this bromine goes. So you will get bromobenzene. So the third reaction, if this is treated with cuprous cyanide in the presence of KCl, same reaction again. This nitrogen gets eliminated as a gas, and this chlorine gets eliminated as a salt or an acid, Cl minus, KCl agate, K plus and Cl minus. So in place of this whole group, Cn goes. So we get cyanobenzene. These three reactions are called as Sand-Meyer's reaction. So benzene diazonium chloride treated with HCl, HBr, or KCN in the presence of cuprous chloride, corresponding substituted products are formed. So when cuprous chloride is allowed to react with HCl, you get chlorobenzene. Cuprous chloride with HBr, you get bromobenzene. If you take copper cyanide and cyanide, potassium cyanide, you get cyanobenzene. The cyanobenzene is also called as benzonitrile. It's also called as benzonitrile. So cyanides are also called as nitriles. Therefore, this will be called as benzonitrile. Now, 3 or 4 more reactions we have to learn in this topic. We will learn the Sand-Meyer's reaction you understood. That is the reaction between benzene diazonium chloride, cuprous chloride, and HCl. Use chlorobenzene. Benzene diazonium chloride with cuprous chloride and hydrogen bromide gives you bromobenzene. Benzene diazonium chloride with copper cyanide and potassium cyanide gives benzonitrile. These 3 are called as Sand-Meyer's reaction. So other named reactions we have, we're going to learn the other named reaction now. water. We will learn cyanides after this. Now, the next reaction is reaction of fluorine. Substitution of fluorine. Substitution of fluorine. The action of fluoroboric acid. Fluoroboric acid. This fluoroboric acid is HbF4. Fluoroboric acid, the molecular formula is HbF4. Fluoroboric acid. Action of fluoroboric acid on benzene diazoxide chloride yields or gives fluorobenzene. Fluorobenzene. This reaction is called as Ball-Scheisman reaction. SCHIEMAN. Ball-Scheisman reaction. So the action of fluoroboric acid on benzene diazoxide chloride gives fluorobenzene. This reaction is named as Ball-Scheisman reaction. So benzene diazoxide chloride is this: C6H5, N double bond N, and Cl. When this is allowed to react with HbF4, that is called as fluoroboric acid, what happens is this H and Cl gets eliminated as HCl. Now, when this H and Cl gets eliminated as HCl, in place of Cl, BF4 goes. So you have a benzene ring here, you have N double bond N, and we have what? BF4. This, when we heat, this molecule will decompose. These nitrogen atoms will get eliminated as nitrogen gas. And from BF4, boron trifluoride gets eliminated as a byproduct. So what else? We have only one more fluorine. That fluorine gets bonded to carbon. Therefore, we get fluorobenzene. We get fluorobenzene. Did you follow this? This is called as Ball-Scheisman reaction. It is not an Sandmeier reaction. Sandmeier reaction, it was direct. Here it is not direct. It's a two-step reaction. So this reaction is called as Ball-Scheisman reaction. So in this aniline topic, what we are learning, coupling reactions are important. Very important coupling reactions. In the previous question papers, they were asked coupling reactions. Now, what are these coupling reactions? Before we could learn the coupling reaction, we should know that amines are basic in nature. I have taught you in the previous classes, since nitrogen has a lone pair of electrons are called as Lewis bases. So any amine for that matter, whether it's primary, secondary, or tertiary amine, they're all what? Basic in nature. Now, this is coupling reaction. This is called as reactions involving retention of diazo group. Retention of diazo group called as coupling reaction. Reaction involving retention of diazo group called as coupling reactions. So when benzene diazoxide chloride is treated with phenol or aromatic amines, corresponding azo dyes are formed. When aniline or benzene diazoxide chloride, when benzene diazoxide chloride, BDC, benzene diazoxide chloride is treated with phenols or aniline or aromatic amine, we can write aromatic amine to be more generalized, aromatic amine. Corresponding azo dyes are formed. Corresponding azo dyes are formed. Azo stands for nitrogen, coloring compounds. Now just observe this. This reaction, this is nothing but benzene diazoxide chloride. Benzene diazoxide chloride. This benzene diazoxide chloride, if treated with, what is this molecule I'm writing? Can you tell me what is this?
Phenol, sir.
Phenol. Now, if I write this hydrogen, this also is phenol. So pH has to be maintained here. pH should be around 9 to 10. So what happens? Now this H and Cl gets eliminated as HCl. When H and Cl gets eliminated as HCl, what we have? We have a benzene ring. We have nitrogen here. We have double bond nitrogen. And you have a benzene ring. And you have Cl. This is called as, this is not Cl. What is this? Is OH, sorry. This is OH. This is OH here. So this is called as para-hydroxy azobenzene. Para-hydroxy azobenzene. This has orange color. It is orange in color. It's a dye, orange colored dye. So this reaction is called as a coupling reaction, or it's called as retention of azo group. You can see this 2 nitrogen is retained. Therefore, it is called as retention of azo group. Now, since phenol is acidic in nature, the pH is around 9 to 10. The same reaction, if we perform in the presence of aniline, here it is NH2. This is benzene diazoxide chloride. This is aniline. Aniline is a base. Since aniline is a base, the solution has to be maintained in acidic. So pH should be between 4 to 5. So what happens again? HCl gets eliminated. What happens? Now, in place of OH, I have to just replace by NH2. Therefore, this will be called as para-amino. This is para-amino azobenzene. This para-amino azobenzene will have yellow color. Para-hydroxy azobenzene will have orange color. Para-hydroxy azobenzene, para-amino azobenzene will have yellow in color. Did you understand this reaction? See this coupling reaction. Coupling reaction, it's important. Very simple reaction. Learn this coupling reactions. So aniline is also done. So the last part of the topic, we have cyanides and isocyanides. If we can finish cyanides and isocyanides, then I think we should finish it today. Then we can have one more session for the MCQs and organic chemistry will be done. Now we will learn the next heading in the chapter amines is cyanides and isocyanides. So cyanides and isocyanides. Now, what are the cyanides and isocyanides? Now, for an example, if I take HCN, HC triple bond N, this is a cyanide form. This is cyanide form. So on nitrogen, we have a lone pair of electron. You should know that. Now, this molecule will undergo tautomerism. Tautomer is an isomer. The 5th class of isomer, tautomerism. We have learned chain isomerism, position isomerism, functional isomerism, metamerism. The next is tautomerism. Tautomerism happens only at equilibrium. So what happens is, now, this will undergo isomerism, change. So what happens is, carbon, it will go negative charge, nitrogen will gain positive charge, and you will have hydrogen. So you can see this is CN, here it is NC. So CN, cyanide is, carbon is bonded to hydrogen here. Here nitrogen is bonded to hydrogen. This is called as isocyanide form. So even in coordination chemistry, we have learned something called as ambidentate ligand. So a ligand which have 2 different types of donor atom. If carbon is bonded donor atom, it's called as cyanides. If nitrogen is donor atom, it's called as isocyanides. So this is an isocyanide here. Now, how do you prepare cyanides and isocyanides? So some of the methods of preparation and chemical properties we have to learn. There's a number of methods of preparation. and also chemical properties. So many chemical properties we have to learn. We will rush through. Did you understand what is cyanide and isocyanide? Cyanide, carbon is a donor atom. Isocyanide, nitrogen is a donor atom. Cn is called as cyanides. Nc is called as isocyanides. The preparation of cyanides and isocyanides. First, we'll learn the preparation of cyanides, and then we can go for isocyanides. Methods of preparation. The first one is called as from alkyl halides. Alkyl halides. Now, nitriles or cyanides. Nitriles or cyanides. Nitrile or cyanides are prepared by heating alkyl halide with potassium cyanide. When alkyl halides are heated with potassium cyanide, so alkyl halide, now for an example, we'll take ethyl bromide, CH3CH2Br. This ethyl bromide, when it's heated with potassium cyanide in the presence of alcohol, alcoholic potassium cyanide, what happens? K and Br gets eliminated as KBr. In place of this Br, cyanide goes. So we get CH3, CH2, and Cn. So this is called as a cyanide because the bonding is between carbon and carbon. So therefore, it is called as a cyanide. So first method of preparing an cyanide or a nitrile is reacting an alkyl halide with alcoholic potassium cyanide. When alkyl halide is allowed to react with potassium cyanide alcoholic, substitution reaction takes place. Bromine is substituted by cyanide. The second method of preparation is from amides. Second method of preparation is from amides. What are the molecules? What's the formula, functional group of an amide? How do we represent an amide?
NH2, sir.
That is amine. Amide, I'm asking. Amide. What is an amide? Example. CONH2 is called as an amide group. Amine is NH2. AMINE. Amine is NH2. This is amide. AMIDE. Amide group is CONH. The CONH bond is called as peptide bond or amide linkage. Remember, we'll learn it in polymers, biomolecules in detail. So this is called as acetamide. Acetamide. This acetamide, when it is treated with or heated with phosphorus pentoxide. Acetamide is heated with phosphorus pentoxide. See, this phosphorus pentoxide is a very good dehydrating agent. So what happens? Oxygen and these two hydrogen gets eliminated as water. When oxygen and these two hydrogen gets eliminated as water, what we have CH3, you have C, and you have a triple bond will be formed between carbon and nitrogen. Cyanides are formed. So the second method is from amides, dehydration of amide. So phosphorus pentoxide is also an example for dehydrating agent. It is a second method. The third method of preparation of a cyanide is from aldooxime. From aldooxime. You know what is aldooxime? We have learned aldehydes and ketones in detail. So CH3, CH, double bond NOH. So this is one of the example for aldooxime. This is called acetaldehyde oxime. We have learned it. When hydroxylamine is allowed to react with acetaldehyde, you get acetaldehyde oxime. This acetaldehyde oxime, when it is heated with acetic anhydride. Acetic anhydride is also a dehydrating agent. So when acetic anhydride is also a dehydrating agent, what happens? This H and OH gets eliminated as water. So what else is left out? You have CH3, You have C. Since H and OH is getting eliminated, another bond will be formed. So carbon to nitrogen, the triple bond will be formed. A cyanide will be formed. So this is also called as dehydration. Why it is called as dehydration? Removal of water. Therefore, it is called as what? Dehydration. The previous example we learned, that is dehydration of amide. When amide is allowed to react with phosphorus pentoxide, dehydration takes place forming cyanides. Likewise, hydroxylamines or aldooximes go on heating with acetic anhydride. Dehydration takes place forming an amide and forming an cyanide. The fourth method of preparing is from Grignard reagent. Grignard reagent. Now, Grignard reagent, an example, we will take a benzene ring. We have Mg, we have Cl. Phenyl magnesium chloride. This phenyl magnesium chloride, when it is reacted with or when it is heated with cyanogen chloride, cyanogen chloride is ClCN. So what happens now? This Mg and Cl gets eliminated as MgCl2. In place of this MgCl, what goes? Cyanide goes. So we have a benzene ring and you have CN. This is called as cyanobenzene. It's called a cyanobenzene. So this is a fourth method from Grignard reagent. So Grignard reagent reacts with cyanogen chloride. What is that cyanogen chloride? ClCN is called as cyanogen chloride. We get cyanobenzene. The next method of preparation is by addition of hydrogen cyanide to alkenes. So we can also prepare cyanides from alkenes. Now, alkenes are unsaturated compounds. These alkenes will undergo addition reaction. So alkenes are unsaturated compound. It undergoes addition reaction. So now an alkene, addition of HCN to alkenes. Now an alkene, we will take a simple alkene, CH3, and CH2. This is an alkene. Now this alkene, when allowed to react with hydrogen cyanide in the presence of alumina as a catalyst and 650 Kelvin, what happens is hydrogen attacks this carbon and cyanide attacks this carbon. So what's that we get? We get CH3, CCH3, you have CH3, and you get cyanide. So this would be called as 2,2 dimethyl. So this is the longest chain because cyanide also contains carbon. So these two will be called as substituents now. 2,2 dimethyl propane nitrile. Cyanides are also called as nitriles. So the IUPAC name for this molecule formed is called as 2,2 dimethyl propane nitrile. Now, these are the methods of preparation of cyanides. Now, we have to learn some of the chemical properties of cyanides. So we will learn the chemical properties of cyanides and then isocyanides later. Reactivities or chemical properties. Reactivities of cyanides.
The screen is not visible.
What?
Sir, it's not visible, sir. Screen share.
Okay. Are you following? Reactivity.
Yes, sir.
Yeah, reactivity of nitriles, or it is also called as chemical properties of cyanides. The first one will be called as hydrolysis. Hydrolysis is addition of water. So now, example, if we take, we will take CH3, C triple bond N. It's a cyanide. This cyanide on hydrolysis gives carboxylic acid and ammonia. carboxylic acid and ammonia. This is hydrolyzed. 2 moles of water in the presence of an acid. See, what happens is the bond breaks between carbon and nitrogen. Water, we can write it as H2 and O. The second molecule of water, we can write it as H and, sorry, I made a mistake. I've written it another. So water, we can write it as O and H2. The other water molecule, we can write it as OH and H. So what's that we get? We get CH3, COOH, a carboxylic acid, and the gas liberated is ammonia. So nitriles or cyanides on hydrolysis, we get a carboxylic acid with the liberation of ammonia gas. The second reaction is addition of ammonia. Addition of ammonia. Now, a cyanide, CH3, C triple bond N. The cyanide, when it's heated with ammonia, and the presence of soda amide, what happens is, now, one of the bond breaks here. When one of the bond breaks, from ammonia, 3 hydrogens there. 1 hydrogen attacks nitrogen. So I can write H and NH2 here. H attacks nitrogen and this NH2 attacks carbon. So we get CH3, single bond C, NH2, double bond NH. So this is called as amidine, AMIDINE. So amidine, this is nothing but a molecule which contains NH2 group, as well as we have a double bond. Those are called as amidines. 2 properties we have learned. Hydrolysis we have learned. The other one is reaction with ammonia. Now the third reaction is reaction of cyanides with Grignard reagent. So Grignard reagent is very important because we can prepare any class of compounds using Grignard reagent. That's the importance of Grignard reagent. So the third reaction, what we're going to learn is addition of Grignard reagent. Addition of Grignard reagent. So we'll take a specific example. CH3, C triple bond M. When this is allowed to react with CH3, MgI, methyl magnesium iodide, it is a Grignard reagent. So what happens is, now the CH3 MgI, we will have Mg as a positive character and CH3 as a negative. Bonded pair of electron will move towards nitrogen. Nitrogen will have a negative character, this carbon will have a positive character. So MgI will attack carbon and this CH3 will attack this carbon. So 1 pi bond breaks. So what's the intermediate compound we get? We get CH3, C, CH3, double bond N, MgI. This on hydrolysis, this on heating it with water. So water we can write it as OH and write it as hydrolysis. This on hydrolysis, you get Mg, OH and I as one of the byproduct, Mg, OH, I, magnesium hydroxy iodide. And the second molecule of water, we can write it as O and H2. So the byproduct, again, one more byproduct is ammonia. So now what happens? We have CH3, C double bond O and CH3. We get a ketone and the name of this ketone is acetone. So this is the reaction. So when cyanides are allowed to react with Grignard reagent, corresponding carbonyl compounds are formed. When we take methyl cyanide, the ketone what is formed, carbonyl compound what is formed, is acetone. Now, the next few reactions, and then we can finish off with cyanides, isocyanates, and the next set of questions. One more class, we'll finish amines also. Maybe on Friday, we should be in a position to finish amines. Now, the next reaction is reduction. You know that reduction is addition of hydrogen. So if you take a specific example, methyl cyanide or cyanomethane, methane, if you take this, when you heat it with a strong reducing agent like stannous chloride and HCl. So since it's a strong reducing agent, it gives nascent hydrogen. One nitrogen attacks this carbon, the other hydrogen attacks this nitrogen. One pi bond breaks. So you get CH3, CH, double bond, NH. This group is called as imines. NH2 groups are called as imine, I-M-I-N-E. Now this when you hydrolyze, so what happens is the bonds break. The bond break here. So hydrolysis, we can write it as water, we can write as H2 and O. So what is that you get? You get on hydrolysis, the byproduct is ammonia, and the product what we get is CH3, CHO, acetaldehyde you get. So cyanides on reduction, the products obtained is always aldehydes. Always aldehydes. Now the last reaction, chemical reaction in the topic cyanides is nitrile condensation reaction, the last reaction. Then we'll go for isocyanides. So the last reaction is nitrile condensation reaction. Now what is this nitrile condensation reaction? We will take a cyanide. The cyanide, we will represent one more cyanide like this. Second molecule I'm representing. The second molecule of the same molecule I'm representing it like this. CH3, CH2, CN, CH3, CH2, CN, the same molecule. This, when you allow it to react with sodium in ether, so it is called as nitrile condensation reaction. So what happens is this hydrogen attacks nitrogen. When this hydrogen attacks nitrogen, a pi bond breaks. So what we have CH3, CH2, you have the C, and this NH is there. We will write this NH like this. So that this carbon is not having a satisfied tetravalency. What else is left out? We have this whole group. So we have CH, CH3, and Cl. So this is called as 3-imino. NH group is called as imine group, imino, 2-methyl. This is 1, 2, 3, 4, 5. 2-methyl pentane. And since the longest chain contains cyanide, it is called as pentane nitrile. It's called as what? Pentane nitrile. So these are the reactions in case of cyanides. We should learn the last part of the topic, that is alkyl isocyanide. We have to learn the preparation and chemical properties of alkyl isocyanides. And then we will learn with the MCQs of the amines. So we will end this class today. Madam?
Yes, sir. Thank you, sir.
Yeah.
Thank you, sir.
Yeah.